I'd like to take this time to welcome you to Elementary Statistics. We're going to start out with what seems like a bunch of terminology. Okay, so we're going to start with some basic things that you need to know and be able to share in order to understand what we're talking about here in statistics. So let's start our slideshow. And the first thing we're going to do, and this is section, as you can see, this is section 1-1, Statistic Basics. What we're going to do is talk about, first and foremost, descriptive statistics. And as it says, it consists of methods for organizing and summarizing data. Now, the thing that I can state the most to you is the organization and summarization part of this. So organizing and summarizing. So if you notice, we've got some examples down here. 80% of the class receives a passing grade. This is a summarization, right? 80% is passing the grade. The Ole Miss Rebels, sorry, Mississippi State fans, but the Ole Miss Rebels had a winning record of 7-6 for the 2012 football season, or we could say 8-5 this year for the 2012 football season. Now, this is actually summarizing the season as a whole, right? The U.S. won 11.92% of the gold medals. That's summarizing, and it's a way of organizing as well. You can organize who, country by country, who won the most based on the percentage of medals they won. So it's another way of organizing data. 80% of the class receives a passing grade. We can use that to organize as well. So descriptive statistics consist of methods for organizing and summarizing information. All right, so in a group of statistics, we have what we call the population. This is the collection of everyone. This is all the people that you're considering in a study. Okay, so for instance, if I am talking about women, it's all the women in the world. Okay, so that would be my population. Now, a lot of times it's not feasible to use to sample an entire population because time consuming, it costs a lot of money. I mean, it's just almost impossible to do. So we have to take what we call a sample. And a sample is a part of the population from which the information is obtained. And so if you look right down at the bottom here, here's an example of what a sample would be. Randomly selected certain members of the population, and we look at their characteristics and to see if the sample describes the population. Okay. Well, we had two types of statistics. You've got your descriptive statistics that organize and summarize, and then you've got your inferential statistics. Consist of methods for drawing and measuring the reliability of conclusions about a population based on information obtained from the sample. So that's a lot of mathematical jargon to tell you this. We're going to take a sample of the population. We're going to look at that sample, and based on what we find from the sample, we're going to use it to try to make a conclusion about the whole population. Okay? So, one way you can think of inferential statistics, the drawing of conclusions, that they're going to help you to, it's going to help you to try to determine a maybe what's causing something. What's causing what does this particular information say about this particular population? For example, if you look at political polling, that's probably our most common example of inferential statistics, because if you think about it, if you're watching NBC, CNN, Fox News, whatever you watch, when they'll talk about taking a straw poll of the people coming out of the election booth. Well, what they're hoping to do is to sample enough people that they can tell you, and they can make an inference. That's where inferential comes from. That they can make an inference or draw a conclusion about how that particular area is going for that president. So if you're doing a straw poll, and for instance on this last election, if you're doing a straw poll and President Obama came out with 80% of the votes in the straw poll of the people exiting, we could make an inference. We could say, well, if 80% of the people coming randomly picked that are coming out are saying they voted for President Obama, then most of the population there probably voted for President Obama. They're trying to draw conclusions based on the information sampled. Okay, so political polling. That's probably one of the best examples I can think of an inferential statistic. Now, what you're going to have a lot of is going to determine whether something is descriptive or if it's inferential. Now, notice what I said here. If the intent of the study is to examine or explore the information just for its own intrinsic value, its own interest, it's not drawing any conclusions or anything like that. You're just, okay, 80% of the people are male. All right. That's descriptive. You're describing that data. Now, if you're taking a sample and from the sample, the whole intent is not intrinsic, the whole intent is to draw a conclusion about the population, then that's inferential. So, notice, again, the key term here is drawing a conclusion. Drawing a conclusion. Okay? So keep that in mind as you're trying to determine if something's descriptive or if something's inferential. So let's look at this example. We're going to classify the following studies as descriptive or inferential. Here's the 1948 presidential election, okay? And we are looking at the data here. Here's the breakdown of votes and the percentages. Now, this particular study is descriptive. Don't get this confused. Just because it's something political, don't necessarily think it's inferential because I said a moment ago that political polling was inferential. Political polling is inferential because we're trying to draw a conclusion based on what we're sampling from the people coming out of the polls. This is just a summarization of the votes, of the data. This is a summarization and an organization of it. So this would be descriptive. You're not trying to draw any conclusions based on this data. Okay, it's just presenting the data to you. Okay, so that would be why it's descriptive. Now, for this particular one, Major League Baseball used Spalding balls until 1976. In 1977, they began using Rawlings baseballs. In 1977, pitchers complained that baseballs were harder and bounced farther, and the hitters had an unfair advantage. An independent testing company randomly selected a sample of 85 baseballs from 1977. The bounce, weight, and hardness of the balls chosen were carefully measured and compared with measurements on similar baseballs from those particular years. The conclusion was that the 1977 Rawlings ball is livelier than the 1976 Spalding, but not as lively as it could be under big league rules or as the ball has been in the past. So basically what this is saying, this is an inferential statement because we're taking a sample and they were trying to draw a conclusion about the 1977 baseballs. They were trying to prove that hitters had an unfair advantage. So they were taking a sample to make an inference about the population. And this also shows that it may not be feasible to do an entire population. Because notice, they were sampling baseballs from 1952. Well, this is 1977. That's 25 years later. They're not going to have every baseball from 1952. So you're only going to be able to take a sample of those areas. So this shows how it may not be feasible to do an entire population. Okay, so we have two types of things here. We have an observational study and designed experiments. These are the two types of the two types of ways we can sample, okay, or we can take data, so to speak. In an observational study, we're simply doing what it says. We're taking some statistics, some measurements, and we're just observing, okay, as in a sample survey. Just observing. So, for instance, this one on skin fold thickness. A study titled Body Composition of an Elite Class Runners was conducted by M.L. Pollock to determine whether elite distance runners actually are thinner than other people. Their results were published in that medical journal. The researchers measured skin fold thickness as an indirect indicator of body fat of runners and non runners in the same age group. Now, this is an observational study. The researchers didn't have any control over who became an elite runner and who did not. They simply observed the skin fold thickness, okay? They simply observed the skin fold thickness. They didn't make any kind of treatment or control, or they didn't do any kind of experiment to it, notice. They just took a measurement and observed what that measurement said. So that is a observational study. Right, a designed experiment. This is the other way we can treat a study, okay? And this involves us taking our experiment and applying a treatment and a control. We'll get more into what a treatment and a control is a little later on, but we're taking these and we're applying a treatment and control, and then you're going to observe what happens, okay? So a control would be something that is not going to change, and a treatment is something like where we're giving them a placebo or we're giving them a new drug or something, and they're trying to see if it works, okay? So let's look at this example. Treating heart failure. In the paper, Cardiac Resynchronization Therapy with or without implantable defibrillator in advanced chronic heart failure, this author reported the results of a study for treating patients who had advanced heart failure. A total of 1,520 patients were randomly assigned in a 1:2 ratio to receive optimal pharmacological therapy or in combination with either a pacemaker or a pacemaker defibrillator combination. These patients were then observed until they died or were hospitalized for any cause. Now, this is a designed experiment because the researchers didn't just take the 1,520 patients and observe them, but instead they randomly assigned patients in a 1:2 ratio. They either gave them they gave them different treatments. They either gave them a drug therapy, they either gave a drug therapy in combination with a pacemaker or a pacemaker defibrillator. So they were given different treatments to different patients. Okay, so this is a designed experiment where you're actually changing the sample. You're applying some kind of treatment to them and then observing the results to see if it changed. Okay, so this is section 1-1, Statistics Basics. If you have any questions, please email your instructor. Have a great day.